Hello and most welcome to the continuation of Terry's interesting article, Marks-Tarlow, Fractal Entanglement Between Observer and Observed. And I would continue where I left off in 1332. And we have just mentioned the historical process and how Carl Jung got interested in the development of imaginary numbers. In terms of mathematical modeling, followers of Jung and Einstein played with the idea that imaginary numbers can serve to unify inner and outer worlds. Imaginary numbers have the unique property in the world of being just in between, just exactly in between. And I can mention for my own sake that when I encountered imaginary numbers when I studied to become an electronic engineer, I was absolutely mesmerized that something that is not of the world, that is the square root of -1, did have an incredible and incredibly important role to play in electronics. I would say no electronics can be made without the aid of imaginary numbers, although they are for all aspects, in all ways of seeing them, completely impossible for reality. They do not exist. The square root of -0 is unimaginable, but still it's usable. And I would say that is the only exception. And this is also why imaginary numbers is the key to understanding how inner and outer can be the same thing. Without that key, no understanding that inner and outer is the same thing is possible. I am firmly convinced that this is the key that opens up the lock. Any proclaimed understanding of a division and complementarity of inner and outer, matter and soul, here and there, without imaginary numbers is not true to the fact. It is a necessary ingredient. Physicist, psychologist Arnold Mindell makes a similar assertion to Einstein and Jung, believing all mathematics to be a code for linking observers with the observed. Metaphorically, Mindell believes imaginary numbers represent qualitative, subjective aspects of experience. Or what he calls non-consensual reality. His thinking is influenced by Wolfgang Pauli, a physicist whose dreams inspired Jung to write some of his most important works. Perhaps Pauli's most famous dream involves an inner music teacher who conceptualizes imaginary numbers as the key to unifying physics and psychology. I also speculate within the arena of imaginary numbers, a method for invisibly unifying previously separated levels. Fractals are cycles of re-entry, recursively iterated on the complex number plane. They described qualitative rather than quantitative aspects of nature. Such as the ruggedness of a coastline or the jaggedness of a mountain chain. Since imaginary numbers model hidden dimensionality. In the case of fractals, this consists of infinite expanses lurking in the spaces between ordinary Euclidean dimensions. Fractals appear to connect as well as separate inner and outer levels in at least two ways. One is by offering a lexicon of complexity, which applies equally as well to nature around us as it does to human nature inside us. The ability of fractals to describe and unify inner and outer worlds helps to flesh out Gregory Bateson's largely unformulated intuition concerning a necessary unity of mind and nature. Secondly, fractal separatrices comprise complex boundary zones between various realms of existence, spanning levels from the lowest material to the highest spiritual realms. Fractal geometry. Clouds are not spheres. Mountains are not cones. Coastlines are not circles. And bark is not smooth. Nor does lightning travel in a straight line. Benoit Mandelbrot. Computer-generated fractals provide the most successful tool ever found for simulating nature. To create a mathematical fractal, a very simple formula, such as the original one discovered by the French engineer Benoit Mandelbrot. Z goes into x squared plus c is iterated recursively for every point of the complex plane. This means that the same formula is plugged in over and over, with the end products fed back in as new starting points. In theory, this continues indefinitely. In practice, it continues until either the equation settles down to a stable outcome, or an arbitrary point is reached indicating a clear direction. when observing a fractal image rendered by computer iteration, three distinct zones are apparent. There is an inside of a fractal, which is the case of the Mandelbrot set, is usually indicated by a solid black zone representing stability. Here on the complex plane, the equation converges to order in the form of periodicity. By displaying one or more stable endpoints. By contrast, the zone outside of the fractal, symbolized by various color gradations, represents the part of the complex plane where the very same equation flies out of control, moving towards infinity at various speeds. The third and most interesting zone consists of the edge between these two. This is the real fractal, which is infinitely deep when the computer is used as a microscope to zoom in at smaller and smaller scales. Here iteration neither settles down to stability nor flies off to infinity. But instead exhibits unceasing complexity, shifting dynamically with the perspective of the observer. Whether rendered on a computer or found in nature, the hallmark of a fractal is self-similarity. Self-similarity is a newly discovered self-reflexive symmetry in which part of any natural fractal bears resemblance to the whole thing. Sometimes this resemblance is exact, as in the case of linear fractals like the Koch snowflake or Cantor dust. Other times, the resemblance is approximate or statistical, as in the case of the Mandelbrot set or other nonlinear fractals. Whereas linear fractals tend to be abstract and idealized mathematical forms. Nonlinear tend to be realized in nature. Clouds, mountains, coastlines, and other branching shapes are all part of the natural lexicon of fractals. With fractals, instead of the whole being greater than the sum of its parts, the whole can be detected within the part of at multiple scales of observation. Paradoxical boundaries. While mountains and rivers appear to be stable things to our Western minds, they are instead continually moving processes that evolve dynamically on various timescales. The fiction of stability and thingness is reified by the English language. As dominated by nouns acted upon by verbs. The dynamism of fractals in nature seems much more consistent with several American Indian languages. Where features such as lightning and coastlines are described as processes using verbs. As embodied in nature, fractals occupy the complex interface between chaotic forces such as that between wind, water and heat, comprising the weather. However slowly they may move, clouds, riverbeds, and mountains are all dynamic processes. They involve recursive cycles of re-entry by which time gets etched fractally into self-similar form. Clouds are fractals whose rapid movement provides a minute-to-minute account of wind and weather conditions. So we continue here. Clouds are fractals whose rapid movement provide a minute-to-minute account of wind and weather conditions. Rivers embody minute-to-minute dynamics, but also globally occupy an intermediate time frame of evolution. The present riverbed is but the latest in a series of configurations whose evolution can be traced on the canyon walls. Mountains and hills have the entire history of creeks, rivers, wind and other weather-related forces etched into their rock surfaces over eons. Fractal dynamics also pervade our bodies. Elsewhere, I suggest that fractals comprise zones of communication and transportation between various organs and subsystems of the body, as well as between the body and the outside world. Blood circulates throughout the body in the fractal branching of arteries and veins. The lungs cycle oxygen in and carbon dioxide out through fractal bronchioles. Even the neural pathways in the brain, our main organ for perception and communication, are fractal. Skin pores, wrinkles, and other markings on the sacs in which humans and other animals are enclosed are fractally distributed. Self-similar dynamics also pervade psychophysics, by which physical stimuli outside our bodies are transmuted to perception and sensation inside. In human physiology generally, as in nature broadly, fractals serve paradoxical functions as boundary keepers, both to separate and connect various subsystems and levels of being. Elsewhere, I also describe the existence of fractals at a more abstract, symbolic level in the psyche. In the paradoxical space between self and other, fractal dynamics arise in human behavior as personality traits manifest in self-similar patterns evident at multiple scales of existence. For example, aggressive people may push others aside, verbally, with overtalk, pushed ahead of others, physically in lines at the bank. While pushing their needs ahead of others in significant relationships. From micro to micro levels, each instance occurs self-similarly at different scales of social observation. From this brief description of fractals as they occur naturally, it becomes clear that self-similar dynamics span the full range of existence, from the most concrete material levels to the most highly abstract and psychological ones. At the abstract level, self-similar dynamics are also evident in the logic of Charles Peirce. Within his triadic system and the semiotics based upon it, the first is the object, the second is the interpretant, and the third is the sign. The sign expresses a general or abstract relation between the first and second, and carries the meaning of this relationship. Because each sign can itself be the first for other signs. Within unlimited semiosis, this system operates as an infinitely recursive network of re-entrant loops, each reflecting back upon the others in self-similar fashion. Søren Briere described an ontological framework of cyber semiotics in order to understand the emergence of form, life, mind, and consciousness. Nature is viewed in terms of multi-level, multi-dimensional hierarchies. Of interrelated clusters that form a meta-heterarchy or heterogeneous general hierarchy. As new levels emerge via related processes, there is a self-similarity across levels by which general, trans-level principles can be abstracted and placed into a Peircean perspective. Potentialities are causally manifested as constraints and forces, while meaning is created by integrating manifestations with potentiality into regularities and patterns. The process continues recursively. With each new emergent level serving as potential for the development of the next. In general, self-similar dynamics appear in the joints, in the space between levels, relations, and dimensions. They supply boundaries that are infinitely deep and paradoxical. I propose that fractals comprise the realus realm of autonomous functioning. Which operates with borders that are functionally closed while remaining structurally open. Fractal dimensionality. The imaginary numbers are a wonderful flight of God's Spirit. They are almost an amphibian between being and not being. Leibniz. As they occur around and inside our bodies, fractals occupy the complicated interface between various forces in nature. As they occur in the psyche, fractals arise out of endless feedback loops between self and other in relationships. Our sense of self, once again paradoxical in being both open and closed, arises dynamically in the transitional space between people. It appears that everywhere they arise, fractals occupy the boundary zone between. This can be illuminated with a technical understanding of fractal dimensionality. As mathematically, fractals reside in the infinitely complex space between ordinary Euclidean dimensions. Clouds are composed of water vapor, zero-dimensional points that occupy three-dimensional space. A coastline is one-dimensional line that occupies a two-dimensional plane. Mountains are two-dimensional surfaces draping a three-dimensional world. Quaternions are products of the hypercomplex plane consisting of one real and three imaginary axes. Because they are three-dimensional shadows of four-dimensional space, if the fourth dimension really does relate to consciousness. Quaternions may provide some clues to the internal landscape of higher dimensional thought. To calculate fractal or Hausdorff dimension, one of many possible ways to measure fractal dimensionality. A log-log relationship estimates the rate at which more information becomes available to us as we shrink the size of our measuring device. Logarithms involve exponents of the powers to which a base number must be raised to equal a given number. For example, the logarithm of 100 in base 10 is 2. We can get a feel for the non-linearity of logarithms by considering the Richter scale. A logarithmic scale measuring the power of earthquakes. On any logarithmic scale, the distance from the origin to any mark is proportional to the logarithm of the number attached to that mark. On the Richter scale, an earthquake of the magnitude 8 is not twice as powerful as one measuring 4. Which would indicate a linear relationship between marks. Instead, a magnitude of 8 is 10 times 10 times 10 times 10 times more powerful than the one of 4. The log-log graph used to calculate fractal Hausdorff dimension plots one logarithmic relationship against another. The rate by which more information becomes available as we shrink the size of our measuring device. In the log-log relationships of fractal dimensionality, a kind of magic becomes evident. An unexpected relationship exists between the observer and the observed. i.e., between the measuring device we use and that which we measure. With fractal objects, because this same relationship holds at every scale of measurement, we wind up with self-similar pattern. With mathematical fractals, the smaller our measuring sticks, the larger the measurement. Because the quantity of measure continually alters relative to the size of the yardstick, we can see that on a deep level, fractal dimension is not a measurement of quantity as we usually conceive it. Instead, it measures the quality of relations between observer and observed. This is what remains constant with the fractals as we change scales. This is also why fractal pattern turns out to be scale invariant. So we get into the juicy stuff, the fractal dimensionality. And I think it becomes increasingly evident that fractality inhabits the in-between. In between dimension 1 and 2, all levels there are fractal. Dimension 1, 0, 1, and so forth. An infinity of dimensions. And this, ladies and gentlemen, this is reality. We will not find dimension 2, 3, and so forth in reality. It is all fractal. So reality in itself is fractality. This is what characterizes what is real. You will not find the other dimensions anywhere. You can look, they will not be there. And fractality is in both outside and inside. Think of the English coastline. The more you measure, the more details and length you get. But it's also obvious that the observer was always already there in the coastline. And I think this is an excellent example of showing how the observer is constantly there. This is of course the discovery of quantum mechanics, but it gets imminently reinforced by fractality because it's visualizable you can see it, and that will strengthen your experience that fractality is what it's really about. You can also call it non-binary, or in between either or and or. This is where reality becomes. It's becoming. It's not static, it is constantly becoming from the outside and in the inside, sort of inhabiting the borderline without actually statically being there. It was a pleasure. I say thank you very much and have a very pleasant afternoon. Bye bye for now.